Welcome back to this channel. In this video, we are going to be talking about the relationship, the mathematical relationship between carrying capacity and MSY. Recall, according to the logistic growth model, we said that the population of fish is going to grow according to this sigmoid curve. And that time we said we actually modeled the biomass at a particular time against time. So B sub t against time. So B representing what? Biomass here. So according to this sigmoid curve, we have that this point is what? The carrying capacity. This is the maximum. This is what we call the biological equilibrium, where the birth rate equals death rate and other factors controlling the population increase there. Now, we also said that this is the point of the minimal increase and point of minimal increase, or why this is the point, so the point of steady and steady increase, why this is the point of rapid, the most rapid increase. And this point of most rapid increase, we said is the point at that corresponds to MSY. Now, how did we get that? We said that we could now model the yield, the amount of fish caught in a particular fishery by modeling the rate at which the B, the T, the rate at which the population increased. So if we take the rate of this thing, we are going to have against the biomass that is available, against the B sub T that is available. So if we plot a graph of this thing, we are going to have a curve like this. Now, when you have this curve, according to this curve, this point corresponds to this point. Now, if you look at it, the fastest rate is this point. So this is the fastest dBdt. Is that okay? And this is the slowest dBdt and the slowest dBdt. Notice it's the dBdt is increasing here. The rate of growth of the biomass is increasing. The rate of increase of the biomass. While the rate of increase of biomass is decreasing at this way. So you see, it's increasing in this way. It's increasing. Then it's rapid here, and it steadies up here and becomes and doesn't increase or decrease at this point. So this point here corresponds to what? Carrying capacity. And this point corresponds to what? To MSY. So what does this show? This shows that MSY point is the point of that divides this 2 into 2. That is what? Point of K over 2. So how do we prove that mathematically? Now, recall, according to the Verloust equation, it said that the BDT now, or you say dNdt, depending on what you're using. I'm going to be using the BDT is equal to RB sub T into bracket 1 minus B sub T over K, where B sub T represents what? The biomass at a particular time. Biomass at time T. While R represented intrinsic growth rate. We said this is this. While R represented what? Intrinsic growth rate. Recall that I said that this is intrinsic growth rate is peculiar for a particular population. All right. Now, what do we have here? Let us open the bracket. We're going to have dB dt is going to be equal to what? RB. This opens the bracket. We have RB minus this times this becomes RB sub T all squared. This times this all over K. Is that okay? Now, in order to get the that slope that we had here, we are going to differentiate this. We are going to take the change of this, the rate of change of this thing according to the biomass. Is that okay? We are going to take the rate of change so that we'll get the slope of that. So we are taking the slope of this. It is the slope of this graph. So it's the slope of this graph, this sigmoid curve that resulted in this shape that we had then. So we are going to take the slope of this. And how do we take the slope? By differentiating, isn't it? So if we differentiate this, we're going to have d squared b dt squared is equal to what? When you differentiate this with respect to t, what you have is this one, because it's singular, because it's 1, I mean, it is, the power is 1. The power of b here is 1. So you're going to have what? Only r. Because this one, if you differentiate For example, if I differentiate 2x, it gives me 2, isn't it? So if I differentiate 1b, it gives me it gives me just 1. So 1 times r is what? R. All right. Minus, if I differentiate this, if I differentiate 2x squared, for example, becomes this times this 4x. So the same way, I'm going to have 2 will come down. So because this is not a factor in our differential, that's why it keeps appearing back. Is that okay? 2b sub t all over k. Now, what do we have from here? We have that. So at that highest point, at that peak here, the rate of change is what? The slope is what? 0. The slope is 0. If we take the slope of this is 0, because this corresponds to only 1 point on this axis, and this corresponds to only 1 point on this axis. And to take slope, recall that slope is what? Change in y without change in x. So you need 2 points at least to get the slope. So, and this highest point corresponds to, because it's this point we are working towards, you understand? This 1 point, you can only take 1 point here and 1 point here. So because of that, the slope here is what? 0. Is that okay? So because the slope is 0, so we have 0 is equal to r minus 2r b sub t over k. So what do we have here? This is going to come to this side. So if this comes to this side of the equation, we have positive 2r b sub t over k is equal to what? Is equal to r. So what do you have here? Since r is on this side and r is on this side, r can take care of r. So we have r cancels r out. So that we have 2b sub t is equal to k equal to, now r has cancelled as the remaining one, right? So we can cross multiply. I have 2b sub t is equal to what? K. So we can divide both sides by 2 and we have b sub t equal to what? K over 2. This shows that the biomass at MSY, because MSY point is the point where the slope is what? 0. This peak here, that's where the slope is 0. So biomass at MSY is equal to what? Half of what? The carrying capacity. And this is the proof of the relationship between carrying capacity. There are also other differences between carrying capacity and the MSY. So, but this is the mathematical relationship between carrying capacity and MSY. I'm going to link other videos that relate to this in the description. Make sure you watch them and see you in the next video. Thank you.